Switch level model. So this is exists only in Verilog. So this is not in PhD. So that is in switch level we can write the Verilog code. So switches means here we are going to use PMOS, NMOS and CMOS transistors. So in the transistor level you can write the Verilog code. So that is why it says switch level model. Okay. So we know, so all the VLSI technologies we are using CMOS. So what is the main advantage of CMOS? What is the main advantage of CMOS? It's because of its low power dissipation. So in VLSI, CMOS is used. So listen, so this is your CMOS inverter. Have you studied this? Studied in digital? So it's a CMOS, simple CMOS inverter. So it consists of PMOS and NMOS. The drain of PMOS, the drain of NMOS are connected together. The third bench. So in CMOS, the drain of PMOS, the drain of NMOS are connected together. Okay. So VDD is connected with source of PMOS, then VSS is, that is ground, is connected with source of NMOS. Okay. So the two gates are connected together. The input is applied at the gate. So generally in FET, so in field effect transistor, always the gate is called the control signal. FET generally, the FET is compared with which device? Do you know it? Huh? Analogy I am asking. So analogy means what is meant by analogy? Similar what we use in day-to-day life. So always FET is compared with the water tap. Okay. So this is inlet. This is outlet. Okay. This is your valve, control valve. Okay. So this is always compared with FET. So in the FET, so this is your gate. So gate is control valve. So depending on the gate value only, your output is FET. So always the gate is compared with the control valve. So the input is source, output is drain. Okay. So listen, see here. So you have PMOS and NMOS. So what is PMOS? P-channel MOSFET. So NMOS means N-channel MOSFET. So for P-channel, so if you apply 0 at the gate, so the inverter will be at the gates, okay? So with bubble. So this is the symbol for PMOS, okay, with bubble at the gate. So without bubble at the gate is NMOS, okay? So if you apply 0 to PMOS, then the PMOS turned on, okay? So if you apply 1 at the for the NMOS, then it will be turned on. So generally in digital we used to say logic zeros and logic ones. So 0 means less voltage or ground value. Okay. So 1 means say plus 5 volt. Okay. So if you apply 0 to PMOS, then it becomes on. Okay. So if you apply 1 to NMOS, this becomes on. Okay. So this is the working. Okay. Based on this only, so we can build any logic devices, that is any logic gates using CMOS. Okay. So second bench form of CMOS, when you have to write the switch level modeling code. Last bench. So if you apply 0 to PMOS, it becomes on. 1 to NMOS, it becomes on. Okay. So this is simple CMOS inverter. So inverter means we know. So if you apply 0, you have to get the high output. If you apply 1, you have to get the low output. Okay. So how it works? So if you apply 0, then what happens? So this becomes on. the, so this is VDD. So this only on. So this circuit is off. So no direct path from VDD to ground. So what will happen? This is on. So this is off. So the circuit will not closes. So all the voltages drops at this place. Okay, since only this is on. Okay. So if you apply 0, then what you will be getting 1. Okay, high output you will be getting 1. What will happen? This becomes off. Okay, this is on. Okay, so all the current passes through ground through this path. So what about at this place? So this is off. No, so this is on. So all the current flows in this way. So you get the low voltage at this point. So 0 will be given. You understand? So if you apply 0, you get the high output. If you apply 1, you get the 0 output. So in any particular time, only one transistor becomes on, one is off. Okay. So the switching activity is less. So that's why you have less power consumption if you use CMOS. Do you understand? So this is simple inverter. So one thing you have to note down. So for one input, you need 2 transistors. Okay, for single input, you need 1 PMOS, 1 NMOS. Okay, so for one input, you need 2 transistors. Okay, so if you have two inputs, then how many transistors you need? 4. That is 2 PMOS and 2 NMOS. So in general, so if you have n inputs, okay, then you need 2n transistors. So this is becoming MCQ. Okay, so how many transistors do we need to implement in CMOS? Okay, so if we have n inputs, then we need 2n transistors. So we need 2 transistors, 1 PMOS, 1 NMOS. Okay, so this is simple inverter. So while writing in Verilog code, so you have to follow this way. Okay, so this is the reserve word to use PMOS. Okay, so PMOS, give the label since you may have more than 1 PMOS. So you give the label, corresponding label. Then you have to write in this order. First output, then input, then control. Okay, output, input, control. So control is always, what is control? Control is always, it's a gate value. Okay, control is always gate value. Your output is drain value. So the input may be always from the source value. Clear? So similarly for NMOS the same thing. NMOS is the reserve word. Okay, or predefined word. It's a switch. Then give the label for NMOS. Then you have to follow this order. Okay. So using this, now let us write the switch level model for the CMOS inverter. Okay. So the same way, okay, module name, codes. The same order you have to write it. So the thing is for CMOS and NMOS, you have to use this lines. Okay. You understand? So tell me module. Okay. So give the label identifier. Then what are the codes? Output. So we can give us out. Okay. So output is the keyword. Out is not a keyword. Out, comma, in. That is in. So out, in. Okay. So you have separate VDD and okay. Input is in. Then so for VDD and ground, okay. So you have to use as supply 1, supply 0. Okay. Supply 1 is for VDD, supply 0 for ground. Okay. So supply 1 is the reserve word. Okay, supply 1. So you can give either VDD, okay, or power. So it's a label. So this is your label. Okay. So VDD or power. So since we have marked as VDD, so you give as VDD. User defined. But supply 1 is predefined. So supply 0 for ground. So again ground is labeled. Okay, this is for reservoir. Okay, so module name. So define your ports, output, input, then supply 1 VDD, supply 0 ground. Okay, then what you have to do? So you have to write for the transistors. 2 transistors you have to write the code. Okay, so for PMOS you have to write as PMOS. Okay, so give the label. So any label P1. Okay, so what order you have to follow? Out, comma, in, comma, sorry, out, comma, in. So what is your in actually? Whatever given in the source. So what is given in the source? It's VDD. So how we have written VDD? So out, VDD. So the final values is control. So what is your control? Then for NMOS, N1, out, ground, in, out. So this is out, so this is ground, in, control. Control is in. Okay, that's all.